Hi everyone, welcome back to Internet Report's Pulse Update, the bi-weekly podcast where we discuss what's up, what's down, what's working and not working, and generally keep our finger on the pulse of how the internet is holding up week over week. This week we're discussing stale data and the problems it can cause. We'll look at issues Slack experienced when its cache data wasn't deemed fresh enough and was seemingly bypassed, as well as some indexing issues Google had, and how Cloudflare experienced DNS resolution issues for around 4 hours on October the 4th. And joining me to discuss all this week is Kamal Shankar, my good friend, colleague, principal internet analyst at ThousandEyes, and genuinely nice guy. Kamal, welcome back to the Pulse Update podcast.
Thanks, Mike. It's awesome to be back on the podcast. You know what? Like, genuinely nice guys, good t-shirt idea.
I think so. I think we have to get printed up there with your picture. Great stuff. So let's start with the download, my TLDR summary of what to know about the internet this week in just a few minutes or less. Data freshness matters, and as we've seen time and time again, stale data can definitely cause some trouble. In recent weeks, data was a bit past its prime seems to have led to a couple of instances. So Slack, a cloud-based messaging app for businesses, stopped loading for some users for 20 minutes in the early hours of Friday, October the 6th. The official cause instance was given as an issue where certain back-end Slack processes were pulling data from the database rather than their cache, which caused strain on their servers. We'll discuss this in more detail later, but for now, it's worth remembering that working as designed doesn't always equate to a good digital experience. In another example of stale data causing disruptions, Cloudflare experienced DNS resolution issues for around 4 hours on October the 4th. This was due to a stale root zone file. I will explore this in more detail later in the episode, but here's a brief summary of what happened. According to Cloudflare's detailed explanation of the issue, a new resource record, Zone MD, was incorporated into the highest level of DNS structure, the root zone, under a planned change. However, some systems were not able to pass the new record, which meant zones couldn't be loaded and served in their entirety, which saw effectively stale entries used as they were available in the memory cache as a result of the last successful pull made on 21st September. The company is set to make changes following the incident, including adding monitoring and visibility. In other news, on October the 5th, Google experienced a search indexing issue that affected the indexing of newly published content during a nearly 6-hour period. As of the recording of this podcast, Google hasn't released an official explanation of the incident. Search is a key element across a number of services, and while in this case the impact appeared to be limited to degradation for a subset of services, it's a good reminder that understanding all dependencies in the complete service delivery chain can potentially assist in reducing impact by understanding specifically where they are and where where you need to either mitigate around it or where you can actually optimize that performance. Google also experienced another disruption around 2 weeks prior to this, impacting Google's calendar. This on September 21st. Some Google Calendar web and mobile users experienced 500 internal errors, which is an inability to process the request when trying to access the calendar on the web's main page and while interacting with events. According to a company statement, the root cause was a software update that triggered an unintended bug, which was then compounded by an increase in invalid Internet Calendar Scheduling, ICS, from Gmail to Calendar. The issues were subsequently mitigated by scaling up the calendar resources, filtering traffic to calendar backends, and then by rolling back the ICS file processing change. This incident provides an important point about updates, which is correlating any proposed changes with some form of validation for the digital experience for the complete service at the same time the update is deployed. This is going to help reduce impact by immediately notifying of any deviation. You have to remember that we're making an individual change to a particular module or particular part of that when we don't necessarily understand what impact that might have on the whole system. So by actually monitoring the whole system and verifying it, you can understand what's going to go on across there. The minute you press your change, you know it's potentially you that's instigated it. You can roll it back or take steps to mitigate that problem there. So that's it for the download for this week. Now let's dive deeper into a few of those outages and some recent trends we've seen. As always, we include the chapter links in the description box below so you can skip ahead to sections that are most interesting to you. And if you haven't subscribed yet, we'd love if you take a minute to hit the subscribe button now. It really helps us out and also makes sure that you're the first to know when a new episode drops. And as always, please feel free to email us at internetreport@thousandeyes.com. We always welcome your feedback, questions and suggestions. And with that, let's take a look at the overall outage trends we've been seeing. So during a 2-week period from September 25th to October the 8th, global outages decreased from 194 to 136, which is a 30% decrease compared to the previous weeks, which was September the 18th to 24th. However, the following week, we observed outages increased by 35%, rising from 136 to 184.
So yes, it's interesting to see that also US-centric outages reflected the same pattern, initially dropping from 83 to 58, which is a 30% decrease, which is quite nice compared to the September 18th to 24. And then outages rose from 58 to 69 the next week, which is a 90% increase.
Yeah. And okay, so we saw rises then across the board within this 2-week period, which is actually in line with the patterns we've observed across previous years. But I'm wondering how that was reflected in the proportion of US-centric outages to the global number. Remembering that we've been seeing US outages make up 40% more of all observed outages for really an extended period this year.
That's actually quite interesting statistic that 40% of them are contributing to the global overall number, which is quite interesting. But from September 25th to October 8th, we actually saw a break in this trend, which US-centric outages accounting for just 38% of all observed outages from September 25th to October 8th. This marks only the second time since April that US-centric outages did not account for at least 40% of all observed outages in given 2-week period, which is quite interesting. The thing is, like, we saw the quite interesting trend of outages going down, and then they actually picked up. But truth be told, we are getting to the post-summer vacation time in Northern Hemisphere, at least, as part of which people are getting back to work, vacations are done, more changes are being executed. So I'm guessing that what we might actually see is going to be increase in these trends.
Yeah, absolutely. And that's interesting you say that. You're getting back to work. We've been work all the time down here in the Southern Hemisphere. So what we're starting to see with that is we actually do exactly what you say there. We're moving close to this trend we've seen in previous years. And it's going to be really interesting to see how that continues. Now, as this fortnight we're discussing here covers the end of September, what I want to take a look at is the month-over-month trends in September. So in September, the total number of global outages observed increased from 727 to 770, which is a 6% rise when compared to August. And then the outages also rose in the US, but at a much steeper rate, increased from 288 to 352, which is a 22% surge, which kind of goes in line with exactly what you were saying then about sort of we're coming out of this Northern Hemisphere summer and we're starting to see the increase.
I think we're going to see this pattern going up, but hopefully I'm going to be mistaken and we're going to have really nice and calm time.
Yeah, the thing to remember about those outages that we're seeing, those, is once you go back and reflect, and we'll cover sort of the notable outages we've seen, we're going to dive into them. But when we talk about these outages, they don't necessarily have to be a user impact or detrimental. Remember, the internet is incredibly resilient. We've got these workarounds and these diverse routes we can take. But also, when we actually look into the details of these outages and actually see those, you can actually see and you can correlate those to different times of the day. So we can actually see sort of a lot of these occurring in what we deem outside business hours. So outside 8 to 5 p.m. or outside 8 till midnight in your case there, but we're sort of going looking at sort of these things there. So to that point then is they're done to cause the least amount of damage.
Which is kind of normal if you think about it. You would expect them to execute these maintenances during the office hours. At least we're in parts of the world where office hours are at the time, right? The funny thing is office hours are always happening somewhere, right? But
exactly.
where are your customers? So that's kind of interesting balancing act. But yeah, it's quite interesting to see all of these trends. Shaping out in a format that we get to see on our podcasts.
You're absolutely right. And before I move on to that, this is a very valid point you made. I was going to say it's always 5 p.m. somewhere, so it's interesting, different balance between workouts. But the thing to that is you're actually right. It's critical to understand where your users are so that you can actually then sort of understand the impact it's going to have. Right. So now with that, let's discuss some of the outages from the last few weeks as we go under the hood. For our first outage, Slack stopped loading for some users for 20 minutes in the early hours of Friday, October the 6th. The instance official cause was explained on Slack's status page and was related to an issue where certain back-end Slack processes were pulling data from their database rather than their cache, which caused strain on their servers. And it appeared that the issue happened due to data that was perceived to be too stale. Essentially, rather than serving the data from the cache, which had been prefetched by the system, the system correctly defaulted to retrieve data from the source. However, as a result of this, it hit a system that wasn't designed to handle so many concurrent requests and subsequently couldn't process all the simultaneous requests. The system then had to issue codes to effect that was ultimately unable to respond. So it sent 500 codes, said I cannot respond to this request found there, which resulted in the user being unable to load any data. So Kamal, do you want to take us through what that actually looks like from a ThousandEyes perspective?
Gladly, Mike. For all of those listening audio only on the podcast, what we are looking at here on the screen is a view of the outage as seen from the ThousandEyes platform. I'll be sure to talk you through it so you don't miss out. And for those who aren't familiar, ThousandEyes is a platform that gives you a great view into the entire digital supply chain. We have ThousandEyes agents across the internet, providing us multiple vantage points to see where disruptions are happening at both the network and application server levels. Visibility like this can be especially useful to help the operations teams quickly identify and fix issues that come up, in addition to creating mitigation strategies in advance that can enable you to minimize impact. So now I'm going to show the Internet Insights share link or snapshot in time that actually shows this outage in a little bit more details. And what we are looking at is timeline, and we can see as indicated by a spike in spike in number of the servers that we are looking here on the timeline, that obviously during this time there was something that was happening. If we click on the purple line, we can see that on October 6th, between 8:52 to 9:05 UTC, we saw the elevated number of errors related to the Slack.
One thing I want to point out here is, and this is kind of, we know what happened here, but it's kind of indicative to saw when we're looking at load conditions. So we said we suddenly hit these systems there. That steps up where we see the number of servers impacted, where you're looking from there. Kind of shows us that this was incremental. So we see these situations where we see lights on, lights off. See there's one there. But when we ever see a step, to me, as a pattern, a man loves patterns, we actually like to think, okay, I'm looking at something here low related. So that suddenly gives us an issue. We're saying, okay, this is an accumulated impact.
Yes, correct. The other thing is speaking about this particular outage, we based on the updates that we received from Slack, right? We know what happened, and you can actually see how these steps correlate probably with backend being overloaded with requests, right? So there's a clear indication of or correlation with essentially what happened. Speaking about it, we can see that we saw a very large number of agents from different geographies trying to reach out Slack, and we can see that pretty much all of these requests or quite large number of these requests were affected. The other interesting thing about this particular view that I always kind of find surprising is actually, within the grouping options of the product itself. So if you click on the destinations by application and you select server network, you're going to quite clearly see that even though this is an outage that was affecting directly Slack, we can see that they were 100% hosted in Amazon. So you can see here two different ASNs from the Amazon indicating that their infrastructure is hosted over there.
That's interesting as well, Kamal, because we're seeing that, and there's another correlation here. So you see with the network there, no other applications being impacted at the same time that are hosted within the Amazon the regions or wherever we're looking there. But also the fact then that we're looking at this, and this is differentiated, this is an application issue or related to the application, because hovering over there, we see 500 errors. So we're seeing, and 500 area is this internal unable to handle the process. I mean, again, covers a multitude of sins, but basically it's saying, it's a choke, it's a plea for help, but it comes back from the server down to there. So straight away we can say, okay, I'm actually reaching the server, I just can't process it, therefore my network's okay.
And yes, the other thing, and one of the benefits that actually this view provides is actually to figure out where to contribute the where the responsibility is. So this is like really easy to navigate, and then straight away you can see like, okay, I can see what's the application that was affected. Okay, like let's dive deep. Like we can see, okay, the infrastructure is within the AWS, and sometimes, for example, this can be very useful in scenarios where content delivery networks are used. CDNs, for example, like if CDN is going to have a problem, it's quite easy to actually group by the server network, and which gives you essentially a view. Okay, I can see that this is related to either Akamai or Fastly or any other network. So I particularly like that view. The other thing to your point is that it actually gives us the indication on what this was. So outage error type is HTTP, and we can see that those are 5xx response codes. Straight away, we know that it's application-related outage, and your operational teams, be it SRE, NRE, or typical operations teams within the network engineering groups are not going to be wasting their times, for something that's straight away identified as application-related issues. So essentially, blame games are not to be happening in these particular scenarios. Like we know that this is application, so issue might as well go to the application team straight away to investigate, because there's nothing for the networking team to do, which then ties us back together to the fact that in enterprises, one of the things that managers and decision makers are actually fundamentally care for is this metric that's called mean time to resolution. So, this has direct correlation with that metric of MTTR, as part of which, by eliminating blame games, you get to the resolution faster.
100%. There's 2 points. Do we have an outage? Who's responsible? And third part, who's accountable to actually make that resolution? But that information is key. So let's take a look. Once we got there, let's dive in. Let's have a look, see what that will look like at another test level. So we looked at this from the Internet Insights perspective. Let's go down a level and actually see what it looked like from an individual test.
So the second view that we have of this particular issue comes from the page load tests. In this particular case, what we are looking at is the page load test that's executed from various vantage points, in this particular case from Africa. And during the outage, we can quite clearly see that page load time for Slack, as indicated during the Slack outage, as indicated by the purple line, went down, which goes to what we were previously saying on this same podcast, that reducing page load time doesn't necessarily translate to the good event, right? Like you would want to think that your application all of a sudden became less heavy, or that you optimized something really fine. No, it just wasn't working the way it's supposed to. So, sometimes things such as this are not necessarily good ones. But, as you can see, we clearly indicated that Slack was having the application-related outage, as indicated by the purple line. Now, if you look at the table view, we can see, statistics for different agents across the Africa. And then if I select one of these agents, we are going to see how this agent looked from the perspective of that particular agent. So here, just before the event has started, we can see that we were getting page load time of 8.82 seconds. And we can see all the elements in the waterfall. However, if I click during this particular time, you can quite clearly see that, certain first elements took significantly less time, and then the page wasn't loading the other elements that we were seeing before. So going back here, this is a normal waterfall during the issue. This is how it looked like.
So that's a really good point, Kamal. And one of the things I want to highlight here is when we're looking at, you're absolutely right, when we talk about page load time improving, and certainly for such a short period of time, when we've made no changes per se, then that's something we actually need to look at concern. But if you look at the elements underneath, what we see there is when we're in this period where we had the reduced page load time, we're looking at basically, we can see that the time it takes to that 500 at the top there, it's excessive one, but everything else then is short durations essentially, but they're style sheets, they're images, they're things that would expect a basic page to load. So straight away by looking at that and then a difference between afterwards, I can see that there you go. What I'm actually looking at now is I'm not retrieving content. So again, we know it's application. We saw that from Insights, but we're getting further into where the source, the potential cause of the problem is, which is something retrieving from the back end.
That's correct. And the waterfall view in general is super powerful because it gives you this granularity that you would expect to troubleshoot issues such as this one, successfully. There are cases when we were looking into the waterfalls for the issues with CDN related issues where it would be pretty obvious that the issue with that particular JavaScript that was hosted at one of these was having a hard time loading. So you can actually, quite easily attribute where the issue is, and then you can work from there. This particular issue was also visible on the HTTP server view, as part of which before the issue, we can see that everything was working fine, and then all of a sudden, during the period of this particular application-related outage, we see the dip to pretty much 0% availability. Availability is nothing else than ability of our application of our agents to execute several steps towards the target of the test itself. So that being said, we are looking for the DNS. We are checking whether we can establish a connection. We are checking whether we can negotiate successful SSL or TLS session. We are measuring time it takes to send and receive the first byte, and ultimately what we are looking for is information on what's the response code that we got from the server itself. So if we get 200 or 300 status messages from the server, we consider that fine. If we get something like 5xx, we know that we are dealing with some issue. So in this particular case, if I click on the Cairo, Egypt agent, I can clearly see that this particular agent was getting 500 internal server error, which is indicative that this was application related. And just going back to what we were speaking before, as clearly visible during this outage, it wasn't networking related event. During this outage, there was no fluctuations in packet loss, latency, or jitter, which indicates that this was purely application related issue, which backs up what we were saying before about the mean time to resolution being a core critical issue. There is no question whether this is something that networking team or should be involved in. Obviously, it's not. This should go to the application team. Application team should start troubleshooting this issue straight away and get it to resolution, which is ultimately going to positively have a positive net effect on the MTTR metric itself.
100%. 100%. And the key point there, I guess, sort of wrapping it up there, is exactly what you said. What we want to do is we want to identify, is there a problem? Where is that problem occurring? And then in this part, we can actually pass it to the applications, to the SREs, CREs, with specific contextual information that they can understand. Here it is. This is a 500 error. It's coming from this system, this server, when requesting this information. They're very targeted, so as you said, can reduce that mean time to resolution and get things back up and going again. So with that, I want to talk about another example of stale data causing disruptions when we're going to talk about a recent Cloudflare outage. Cloudflare experienced DNS resolution issues for around 4 hours on October the 4th. So the company provided a detailed explanation of the issue, which began as a new resource record, ZoneMD, was incorporated at the highest level of DNS structure, the root zone. This was done as a planned change. Now, while the root zone was retrieved as normal, Cloudflare's 1.1.1 DNS resolver appears to have problems passing the new record. And as a result, it kept relying on a known working version that did not contain the new record. The outage occurred weeks later then, so this is a bit of a slow burn. So as Cloudflare stated, the DNS signatures in the version of the root zone that were successfully pulled on 21st of September expired, and consequently there was no newer versions that Cloudflare resolver systems were able to use. So Kamal, before we move on to that to discuss this, can you give us a brief overview of ZoneMD and why and how it can be used?
Yeah, it's a new resource record for the DNS. The idea here was to introduce the digest for complete zones, right? So essentially, the zone in this particular case would be a root zone that contains information on like all the ways to so to say redirect the traffic towards the TLDs and stuff like that. And the idea here is to provide complete digest for the complete zone. So if you think about it, like it's an interesting feature, to a certain degree similar to DNSSEC, but DNSSEC goes to very granular level. Well, this is a digest for complete zone itself, which is quite interesting from the. Some of the challenging perspectives. So, for example, if the zone is really large, that means and frequently changes. That means that you are going to keep on calculating digest itself very often, which is like interesting challenge by itself. But while TSIG or T-signature for zone transfers is used for the transport security of the zone transfers and stuff like that. This is just a digest. So essentially, you calculate the hash value that you can check as part of your security considerations. That's essentially what they were trying to do. And in this particular case, the real interesting thing is that Cloudflare was ingesting data for some 14 days that they couldn't parse before noticing it based on the server fields, right, on the DNS. That's the most interesting aspect of this outage, in my opinion.
Yeah, absolutely. So to your point there, the change took place several weeks before, but it didn't become apparent. So this was, like I said, this slow burn. It was sitting there, they're waiting there. And then they identified the issue with a rise in serve fail error codes. Now, like serve fail error codes, a little bit like 500s or 5xx's, sort of cover a multitude of reasons there, but it does give us some sort of indication of what was happening there. One of the attributed causes could be network connectivity, but if we look at this in the context, including the timing of the instance, we said it becomes there, and as you say, timing it to the zone MD, which is essentially providing some sort of validation for that whole digest there. It became probable that this was related to that DNSSEC. So I'm talking about time. I'm talking about the expiration. So we actually, when the DNSSEC timed out on the 4th of October, from there, then we started to see this rise in server fail error. So it's actually that validation error at that point. Before that, we're using old stuff.
But it's also a very good example of how changes on the global infrastructure can affect you, right? So they were ingesting this root zone information just to speed up their own queries. So essentially, their blog goes into quite a good amount of details on actually, what are the mechanics and what they were trying to achieve. But the interesting thing here is the fact that, they were relying on something down the digital supply chain, so to say, and that supply chain effectively changed, and given the fact that it was probably working for years in a way that it was supposed to be working, this new change down the digital supply chain directly affected them. But overall, they showcased very good ownership, and they moved really fast towards the resolution when, what was perceived to have like negative end user effect was observed, right?
Absolutely. And again, kudos to them. You said the blog post is really good. It's very detailed. It explains what's going on, lays everything out. The information is very good. And to their credit, again, they said they recognised that there was a potential gap in some of the monitoring, as you said, about understanding that it wasn't being passed correctly. And they're looking to actually change their processes and how they actually do that to make sure this doesn't happen again. So that's all good. But again, I'll come back and just sort of wrapping this one up there then is this concept again, where there's one small part, we're talking about the DNS, which is essentially, I'm saying one small part, it's a foundational component of actually making these connections coming across there. But the fact if I can't resolve the name, I can't move forward in this process. And if I can't trust it, I can't basically send that information out there. So it's critical to be able to understand in two aspects here. It's critical to understand my end-to-end delivery, all the dependencies, all the components that make that up. So as you said earlier, so I can actually reduce that MTTR, I can actually reduce the impact on my users, and I can maintain that digital experience, but also understand my processes are going on. And if I need to have sort of different monitoring systems that look at different canaries or different triggers within there, then they need to be included to give it that holistic perspective of that overall service delivery chain.
And to be completely fair, it's a very hard thing to do, right? But it's something that we as a field and we as engineers, be it network engineers, software developers, regardless of SREs, NREs, we need to strive for. That's a crucial one, to prevent situations such as this one from happening in the future.
Exactly. We're always learning, always building this stuff up, and we'll see these things occur, and you understand from these patterns, and then we can put stuff in place, to build up from there. And I think that's the key there. So Kamal, it's been an absolute pleasure as always, mate, and I really hope to have you back again really soon.
Thank you so much for the invite. I always have a really nice time speaking to you, Mike, and hopefully we can do this sooner rather than later.
Absolutely, mate, absolutely. So that's our show. Please like and subscribe. We really appreciate it, and it's valuable to us. As I mentioned at the top, not only does this ensure that you're notified as soon as a new episode is available, but it really helps us shaping the content of the show for you. So follow us on X, formerly Twitter, at ThousandEyes, and any questions, feedback, or guests you'd like to see, please send us a note at internetreport@thousandeyes.com. So until next time, goodbye.